Our discussion so far was focused on algorithms for individual relation operations, such as join, select, or set operations. While running our queries, we need to evaluate expressions containing multiple operations. We have different models for evaluating multiple operations in an expression. The simplest model is to keep the result of each evaluation in a temporary relation. The results in the temporary relation are then used for subsequent use by other operations that are appropriate order that yield the proper evaluation of the expression. These temporary relations, unless they are very small, must be returned to disk. The simplest model using temporary relations is called Materialization Model. An alternative approach is to evaluate several operations simultaneously in a pipeline. This means the result of one operator is provided to another operator without creating a temporary table to hold the intermediate results. This model is called pipeline model. The names iterative or volcano model may also be used for it. The pipeline model can also be implemented to work for batch tuples instead of single tuples. In this case, that is called the vectorization model. The operator's internal loop processes multiple tuples at a time. In this section, we will examine the materialization and pipelined tuples. When the output of an operator is saved in a temporary table for processing by the next operator, we say the tuples are materialized. These intermediate results, materialized into temporary relations, are written to disk. For example, say we have two relations, department and instructor. The given array expression, project name, on the result of selection with building name specified on the department relation, joined with instructor relation. We want to know what is the process for materialization model. For this expression, first, the temporary relation holding the tuples that are output of the select operation will be computed and stored. Then, the result of joining this temporary relation with the instructor relation is generated and stored. Finally, the result of projection on the temporary relation resulted in the join step produces the final result to the expression. This evaluation is called the materialized evaluation. Materialized evaluation is always applicable because it includes all the steps required and works step by step on the intermediate relations produced. However, the cost of evaluation is not just a simple sum of the cost of operations. This is because in each step, the materialized evaluation produces temporary outputs. And these temporary outputs are to be written to disk. This makes the cost for materialization quite high.